This video is for Algebra 2 Honors Unit 2B test. So let's go ahead and get right into it. This first one, pretty much everybody got this one correct, but I'm still going to go through the solutions here. So we're going to start off. We have we're going to start off with A times C. And we need two factors of -70 that are going to add up to -3. So our factors of 70, let me see, we've got, hey, what about 7 and 10? So we're looking at -10 and +7. So we have x minus 10 and x plus 7. All right, these are the factors of the quadratic expression. And then we've got to divide by 2, divide by 2. So we have x minus 5 and x plus 7/2. And we know for the solutions, we're just going to take the number portion of the binomial and switch the sign. So we're looking at x equals 5 and x equals -7/2. All right. Our solution set here, again, most people got this one correct. Looking at the fact we can factor out 3. So we have 3 and then x squared. Get this. All right, there we go. Factor out the 3, x squared minus 4 equals 0. Then we can divide out that 3, and we just have x squared minus 4 equals 0. Now, we can recognize this as a difference of 2 squares and say, well, that factors out to x plus 2, x minus 2 equals 0. We set each factor separately equal to 0. And we know, once again, we're going to have 2 and -2. The other thing, when we have a squared term, an x squared with no x, or it doesn't matter what variable it is, variable squared without the other variable, we can isolate the variable. X squared equals 4, take the square root, and we still get x equals positive -2. And number 3, also a lot of people got this one correct. We have a classic quadratic. We just have to set it up properly. It needs to be set equal to 0 because now we have the variable squared and the variable. X squared plus 9x minus 36 equals to 0. We need two factors of -36 that are going to add up to 9. And of course, we're looking at -3 and 12. So we have x minus 3, x plus 12 are the factors of our quadratic. And I'm not going to show here setting each one separately equal to 0, and then that flips the sign. So we're looking at -12 and +3. Okay, now we want to describe the roots of this equation. This is where we started running into some trouble here. All right, describing the root, we know we're talking about our discriminant, b squared minus 4ac. We're looking at 7 squared minus 4 times 2 times 7. And that equals 49 minus 4 times 2 is 8 times 7 is 56. So 49 minus 56. Doesn't matter what that number is now because we see it's going to be a negative number. So we're going to have 2 imaginary roots. Remember, our imaginary roots always come in pairs. There's one, there's going to be another. Let's go ahead and put that as equal to -7. All right, this one here, location of the vertex. All right, so the first thing we need to do is find our axis of symmetry. So our axis of symmetry, x equals a negative, and then let me go ahead and show it. B divided by 2a. So that's going to be a negative, b is 6, divided by 2, and a is -1. So that's 6 divided by 2, that's negative, that's going to come out to 3. All right, and now we can eliminate these three answer choices. Because remember, our axis of symmetry is the x-coordinate of the vertex. And now we're looking at the y-coordinate is going to be the negative of 3 squared plus 6 times 3 minus 10. Very important that we keep that negative outside. So that is equal to the negative 9 plus 18 minus 10, and that equals negative 1. So our vertex 3, negative 1. Now, where does this function, where does the graph of this function cross the x-axis? Recognizing this is in factored form, we need the solutions. The solutions are the roots, which are the x-intercepts. So we change the sign here. Well, I should do it this way. Talking about our x-intercepts, we got something comma 0, because the y-coordinate of our x-intercept is always 0. So something comma 0 and something comma 0. What's that something? Well, we take this number here and change the sign. So that's 3, 0. We take this number here, change the sign. Negative 5, 0. 3, 0. Negative 5, 0. Vertex form of this function. Here's where we have to complete the square. So the vertex form, we're looking at x squared minus 8x plus. Now we want to take this number, the absolute value of b, divide it by 2, and square it. Plus 15. Now we're all on the same side of the equal sign. So since we added this right here, in order to keep everything balanced, we have to subtract it over here. It's like, well, why did we add it there if we're just going to subtract it anyway? Well, that's so we can set up our factors to get the, or set up a perfect square binomial and get this into vertex form. All right, so this gives us x squared minus 8x. 8 divided by 2 is 4. 4 squared is 16, plus 15 minus 16. Now we're going to have our perfect square binomial. This is equal to x minus 4 squared, and that's minus 1. So that one right there. Now we want the solutions for this one. We're going to have to use our quadratic formula because, as we can see here, we do not have rational solutions, all irrational. So let's look at this. We've got, I'll go ahead and write it out just because. Negative b plus or minus the square root b squared minus 4 times a times c, all of that divided by 2a. Now let's go ahead and substitute. B is negative 6, so we've got negative 6 plus or minus the square root negative 6 squared minus 4 times 1 times negative, make that look better, negative 11, and that being divided by times 1. So this is going to give us positive 6 plus or minus, there, that's better, plus or minus the square root 36 plus 44 divided by 2. So we have 6 plus or minus the square root of 80, all that divided by 2, and 80. All right, let's look for perfect square factors of 80. 80 divided by 2 is 40. So we're looking for the largest perfect square less than 40. 36, well, we know 36 is not going to go evenly into 80. 25, no. 16. 80 is equal to 16 times 5. 80 divided by 16 is 5. So we have 6 plus or minus. We're going to take out the square root of 16, 4. That leaves us with the square root of 5 divided by 2. We have 6 plus and minus 4 square root of 5. But we're dividing by 2. We have to take into account and simplify this fraction. So 6 divided by 2 is 3, plus or minus 4 divided by 2 is 2, square root 5. 3 plus 2 square root of 5, 3 minus 2 square root 5. All right, the solutions to this equation. Quadratic formula once again. I'm not going to show it this time. Now we're looking at negative 8 plus or minus the square root 8 squared. Wait a minute. We need this to be set up properly. Negative x squared plus 8x minus 18 equals 0. All right, so 8 squared minus 4 times negative 1 times negative 18. That's divided by 2 times negative 1. Now, what we could have done is said we could have multiplied everything through by negative 1. So we have x squared minus 8x plus 18 equals 0. We're going to end up at the same answer, but I'm just going to go with this right here. So this gives us negative 8 plus or minus the square root of 64 minus 72. So negative 4 times negative 1 is positive 4 times negative 18 is negative 72. That's divided by negative 2. So we have negative 8 plus or minus the square root, negative 8 divided by negative 2. We know that negative 8, we can write this as the square root of 4 times 2 times the square root of negative 1. So now this time we're going to pull out that square root of 4, which is 2, times the square root of 2, and the square root of negative 1 is I. And that's divided by negative 2. Okay, now let's simplify this fraction. Negative 8 divided by negative 2 is 4. Plus or minus 2 divided by 2. Now, it doesn't matter that we have 2 divided by negative 2 because we're considering the positive and the negative to get our conjugate pair here. So 2 divided by 2 is just 1. And to match what we have in our answer choices, 4 plus or minus I square root 2 is our conjugate pair. And there's our answer. Now, if we want to know which one will have exactly one real root, that takes us back to our discriminant. One real root means our discriminant is equal to 0. So let's look at our first one. We have b squared minus 4 times a times c. That is equal to 16 minus 32. That definitely is not going to equal 0. Move on to our next one. 4 squared minus 4 times a times c. That's going to give us 16 minus 64. That's even further away from 0. Let's look at our next one. 8 squared minus 4 times a times 16 gives us 64 minus 64, and that indeed does equal 0. So x squared plus 8x plus 16 will have exactly one real root. All right, solving this equation here. A lot of people got this one correct also. And, well, let's go ahead and put this here. We've got 3x squared minus 6 equals 0. And over here, 3 times negative 6 equals negative 18. Factors that add up to negative 7. We're talking about negative 9 and 2. So we have x minus 9 x plus 2. Then we have to divide by a, divided by 3, divided by 3. We have x minus 3. And x plus 2/3. And once again, we set each factor separately equal to 0. And when we solve that equation, it flips the signs. So we're looking at, now, again, I like to put my numbers in numerical order. So we're looking at negative, I'll guess this here, negative 2/3 and 3. All right, and that's it. And that is how we write our solution set. We do not have to put x equals. So we just leave it at that. Those two numbers separated by a comma in the curly brackets. That is how our answer is correctly written for this one. All right, our next one. Something similar here. All right, so we know, first of all, we need to isolate this squared portion, isolate this binomial. So let's start off subtracting 9 from both sides. And then we got to clear the fraction, so multiply everything by 5. Now we're ready to take the square root, positive and negative 5, and we know that's going to give us two linear equations to solve. 2x minus 7 equals negative 5, and 2x minus 7 equals 5. Go ahead and add that 7 all the way across. 2x equals 2. 2x equals 12. Divide by 2 all the way across. X equals 6, and x equals 1. Those are the two solutions. And once again, 1, 6. That is how we write our answer. We've got to keep in mind when it comes to quadratics, we have two solutions, except in that case when we have one real root, which we've looked at where our graph touches and turns at that one point. All right, but other than that, we've got to have two answers, two solutions. A lot of people lost points on this one because they only put one of the two solutions. All right, so we've got to keep in mind all of these conditions and facts about our quadratics and other concepts that we study here. All right, moving on. Number 13, what is the solution set? This one is just connecting concepts here. We know the solution set, we're looking for the x coordinate of these points, our x-intercepts. And we see that's negative 3, 0. That's 3, 0, but we're only interested in the x-coordinate when we write our solution set. All right, this is another one where we have to connect the concepts. Our zeros, solutions, x-intercepts all mean the same thing. So which one has two x-intercepts? And that is this one right here. A lot of people got this one correct also. Good. All right, factors. Now, this is where a lot of people lost points they should not have lost. All right, so we are crossing at negative 2 and 1. So our factors are x plus 2 and x minus 1. And for those, it did not matter whether or not you put them in parentheses. I'll just show one of each. So it says factors of the polynomial. The reason for the parentheses is that we want to show that x plus 2 times x minus 1, when multiplied, you know, that's what it means to be factors. When they're multiplied, they will give the polynomial that would create this graph right here. So we can think of this as the factored form or the intercept form of a quadratic equation, x plus 2 and x minus 1. All right, this one here. Okay, so we want to sketch a lot going on in this one. So let's go ahead and get to everything here. State the x-intercepts. Well, we have to solve in order to get the x-intercepts. We have -8 and -2, so that means we're looking at -4 and 2. So our factors, x minus 4 and x plus 2, which means our x-intercepts, a lot of people did this correctly. There are still some who did not, but our x-intercepts (4, 0) and -2, 0. The y-intercept, we have the shortcut, but I want to go ahead and show our y-intercept is f of 0. So we're looking at 0 squared minus 2 times 0 minus 8. And once again, our shortcut, the y-intercept is just going to be that number right there, written properly. It even tells you, stated as an ordered pair. Okay, for both of them. So we're looking at 0, -8. Now for the vertex. Well, in order to get the vertex, we need to know the axis of symmetry. So the equation of the axis of symmetry, we're looking at, we know x equals negative b divided by 2a. So that is negative b is -2 divided by 2 times 1. So that's -2 divided, or negative 2 divided by 2, that's 1. So we have x equals 1. A lot of people just wrote out this right here. But again, from the notes and from the videos, the axis of symmetry is an equation in x. X equals a number. So x equals 1, if you wanted to get full credit for that. All right, now we can write the vertex. So the vertex is f of 1. So look at 1 squared minus 2 times 1 minus 8. So that's 1 minus 2 minus 8, and that equals -9. So our vertex, didn't want to do that, there. We have our vertex at 1, -9. And then the last part of this one was to sketch it. So we have our intercepts at -2 and 4. We have 0, -8, and 1, -9. Let's see, that's already, and show it like that, going through. And really, we should have arrows on them to show that it continues on. Okay, this one here. Let's see, the domain. The domain was all real numbers. All right, I don't care how you convey that. Well, actually, I do, but whether you put negative infinity to infinity, but if you do that, both infinities had to be surrounded by parentheses. A couple people were like, well, you know, how do I get the all real number symbol? Well, you don't need it. You can just type all real numbers. The range. The range we're looking at from 3 to infinity. Got to have the bracket and the parentheses in order to get the credit for that one. Or you could say y greater than or equal to, there we go, 3. Now let's see what else. The vertex 2, 3. And we can see that the vertex is a minimum. All right. So again, not a whole lot to explain with that one right there. And we can move on to our next one. And we want to see which is most like the equation here. We look at, we went over 2 and up 1. So our vertex is 2, 1, which means we're looking for a -2 and a +1. So let's start with the -2. We can get rid of that. We can get rid of that one. -2 and +1. There's our answer right there. Okay, we want to find our solutions here. Okay, let's get. Now, really, just looking at it, none of our other answer choices make any sense. We've never written our imaginary numbers in any of these forms, so I guess this one could have been more difficult. But anyway, let's look at this here. We've got -6 plus or minus the square root of 6 squared minus 4 times 1 times 13. That's all divided by 2 times 1. I got 2. Oh, well, made it worse. All right, so that is, okay, there we go. -6 plus or minus the square root of 36 minus 52 divided by 2. That gives us -6 plus or minus the square root -16 divided by 2. We recognize 16 as a perfect square, so we're looking at -6 plus or minus 4i divided by 2. And now, last thing, we need to simplify this fraction. So we have -6 divided by 2 gives us -3. And 4 divided by 2 equals 2. All right, our axis of symmetry. This was another one. Let me see. I'll show it this way. We know our axis of symmetry is going to be midway between our x-intercepts. We have x minus 7 and x plus 3, so that means our x-intercepts are going to be at -3 and +7. That is a difference of 10 units. So our axis of symmetry is going to be midway between, that's 5 units. So we're going to be 5 units away from each one of these, which puts us at 2. So our axis of symmetry, I'll just go ahead and write it, x equals 2. And that's all you had to put. That's what you needed to put, I'll say that way. Some people just put the number 2 and they lost points because of that. Just like on the one a couple of problems ago when the axis of symmetry was x equals 1. Some people just put 1. It's not going to cut it. You have to show it properly. You must convey your answer properly. All right. Hey, I changed this one. The y-intercept of this function. Okay. We know the y-intercept again is f of 0. So we're looking at 0 minus 3 squared minus 8. That is -3 squared minus 8. So now we have 9 minus 8 equals 1. And again, the y-intercept must be written correctly. If you just put 1, did not get credit for that. Some people put y equals 1. That also is not correct. Y equals 1 is this line right here. That is the line y equals 1. We must show our answers correctly. So the y-intercept is 0, 1. All right, now we want to write this one in standard form. Okay, I knew something wasn't right. We skipped number 17. Okay, we want to know the vertex form of this quadratic. So let's start off with the fact that our vertex 1, 2, 3, 4, -4, -2 is our vertex. So we're looking at y plus, oh, y equals x plus 4 squared minus 2. Now that appears to be the answer, but if we look at this right here, we have a point -2, 6. So let's look at something here. If we set this up, does 6 equal -2 plus 4 squared minus 2? So over here we have -2 plus 4 is 2 squared minus 2. 4 minus 2 equals 2. So that tells us this is not the equation here. And if we look at this, this looks a little skinnier here because we also have the point, have this x-intercept 0, -3. All right, so if we make a change here, does 6 equal 2 times -2 plus 4 squared minus 2? So that's 2 times -2, that's still 2 squared minus 2. 2 times, I'll do it this way, 4 minus 2, 8 minus 2 equals 6. So our equation here, and this is something, I didn't take points off, but it says write the vertex form equation. So you need to have y equals or f of x equals 2 times x plus 4 squared minus 2. So again, that exactness detailed. It says write the vertex form equation. If you leave off the y equals or the f of x equals, you don't have an equation. You just have an expression or a mathematical statement. And that is the same thing. Let me see one more here. Writing this one in standard form. A lot of people did not put y equals or f of x equals. But we've got negative, square this out. And I want to show, I'll show it. X plus 4 squared is x plus 4 times x plus 4. And we can use our distributive property, FOIL method, box method, whatever. We have x times x is x squared. I also want to point out that's equal to, I'll keep pointing this out because I mentioned in one of my other videos, this is something you must leave this class knowing how to do this binomial expansion. All right, so we have that's x squared plus 4x plus 4x plus 16, taking the negative of all of that, plus 10. I'm going to go ahead and add my y equals. All right, so here, this is our x squared. That's 2ab, and that's b squared. So this is going to be, once we distribute that negative, y equals negative x squared minus 8x minus 16 plus 10. And I'll go ahead and write the answer up here in the box. Y equals negative, x squared, make that look better, negative x squared. This thing's off a little bit here. All right, negative x squared minus 8x, negative 16 plus 10 minus 6. And again, it needs to have that y equals, or else it's not an equation. It's just an expression. All right, and that is it for this video. Psych. There's one other thing I want to point out with that number 17. I want this to be clear here. Clear that out. We know we had, it was y equals a times x minus 4, x plus 4. X plus 4 squared minus 2. All right, so this is, we know it's a. A, most of our problems, a has been 1. This time, again, going back to the fact that we have this point right here. So now we've got to say that 6, and we said negative 2, 6. So that y value 6 has to equal a times negative 2 plus 4 squared minus 2. So 6 equals a times, that was 2 squared minus 2. Now 6 equals 4a minus 2. So 8 equals 4a. So 2 equals a. So that is where I got the 2 from. Didn't make that as clear as I should have when I first went through it. So again, that is how we get our y equals 2 times x plus 4 squared minus 2. And now this video is officially done.